Figure 1 shows air inside a cylinder with a movable piston. So here you can see the air and the piston can move in and out. The piston is pulled a little way in the direction of the arrow but stays inside the cylinder. Which of these increases? So remember, you're not letting any more air in or out, so the mass of the air in the cylinder will stay the same. The rate at which air particles collide with the walls of the cylinder would actually reduce because there'd be more volume inside, so they have to travel further to collide, so it wouldn't increase. The volume of the air inside the cylinder, so yes, they'd take up more space. There wouldn't be more air, but the volume in which the air occupies would increase because you're moving this out. There's physically more space for them to move in. The pressure of the inside of the cylinder, well, that would drop because the volume has increased. And pressure is a measure of how frequently particles collide against the surface, creating a force, and if there's more volume, it'll take them longer to collide, so pressure drops. Figure 2 shows a rubber tube that can be used inside a bike tyre. The tube is inflated with a bicycle pump, so you can see before and after. What's the question? The air inside the tube exerts an outward force on the wall of the tube. So the air inside the tube exerts an outward force on the wall of the tube. So you can see that here, an outward force there, acting there and there. The question says, state the angle that this outward force makes with the wall of the tube. So basically, it's colliding with the tube and it's hitting it, and the force will be basically at right angles to the wall of the tube. So you can see here, when it's collided, it's at right angles. Interesting question. So you just say 90 degrees, or right angles. It takes 4.8 litres of air from the atmosphere to inflate the empty tube to a pressure of 400,000 pascals. Always underline the important things as you go. Atmospheric pressure is 100,000 pascals. Calculate the volume of air inside the tube. You can assume the temperature of the air inside the tube is the same as the temperature of the air outside. So in other words, temperature is not affecting the pressure. Use an equation selected from the list of equations at the end of this paper. So if you look, we've got volume and we've got pressure and we've got another pressure and we want to work out volume. So it's pretty obvious which equation you need. You need to use one which calculates pressure or volume for gases of fixed mass at constant temperature. So P1 times V1 equals P2 times V2. So how many marks is for? It's for 3 marks because you need to rearrange a bit of the equation. So let's have a look at this. Firstly, you need to substitute the figures in. So we know that it takes 4.8 litres of air from the atmosphere to inflate the empty tube. So that's how much air from the atmosphere is required. And the atmospheric pressure is 100,000 pascals, not the tube pressure. So remember not to mix these up. That's where you can make a mistake. You're marrying this figure with this figure, not this figure with this figure, because this is air from the atmosphere and this is atmospheric pressure. It's really important that you look at the language there, otherwise you'll get this wrong. Then you have 400,000 as the pressure inside the tyre, but what you don't know is the volume of air inside the tyre or the tube. So once we've done that, we just need to rearrange it. Now, because everything has been multiplied by 400,000 on this side, and you want to isolate this, all you have to do is divide by 400,000 on this side to get rid of it on this side and bring it over to this side. So you divide this by 400,000. So you do 4.8 times 100,000 divided by 400,000, and that will give you 1.2 litres. So you get a mark for picking the right equation, you get a mark for substituting the right figures in, rearranging and obviously getting the answer. When a bicycle pump is used to inflate the tube, the air in the bicycle pump gets warm. You should ignore any effects of friction in the pump. Explain why the air in the bicycle pump gets warm. The wording of this one is quite tricky. So basically, if you think about it, warmth is really a measure of the kinetic energy of the particles. So the faster they're moving, the warmer something is. So why does pumping cause them to move faster? Why does it increase more energy in their kinetic store? Well, if you think about it, if you're pumping a bike pump, you are doing work. You are physically working hard to basically pump or force air into the tyre. Now, when you are doing work, you are carrying out energy transfer. So you are basically transferring energy more energy into the kinetic store of the particles. So work is done in compressing the air and therefore reducing the volume of gas that's inside the pump. And this increases the kinetic energy of the particles. This is definitely a higher level question, which I wouldn't expect a lot of students to get because the wording is quite fussy. But remember, if something's getting warm, it means the particles are moving faster, so refer to kinetic energy. And obviously it makes sense if you're forcing air in, it's rushing in, all those particles are knocking into each other, so that is going to increase their movement speed, which is indicative of the amount of kinetic or energy in their kinetic store.